Hi, welcome to this video on National 5 Chemistry for Scotland. In this video we're going to go through a question in the SQA exam paper from this year 2025 and we're going to look at section 2, question 12, the last question in the paper. If you are studying for next year's exam, make sure you have a copy of the paper. You've probably done this paper and you're coming to check how you would approach each of these questions. One of the things that they don't tell you in the marking instructions, which are published alongside the paper, and you can get the links below for those things, you will find that the marking instructions just give you the answers and they don't give you the working out or maybe the thinking process for questions. So that's what this video is for, is to help you with the working out and the thinking process. And maybe if you see that your answer was wrong for the question, you can come to this video and you can find out maybe why. Now, at the moment, the marking instructions have not been published for this paper. If you want to follow along with this paper, there are various places to get it on the internet, which I will help you out with, maybe in the comments. But if you look at the comments or in the description of the video, if you look at the comments of my other videos, you might find somebody else helping you out there. But I just want to check that link is accepted by SQA before I pass it on. But you can find it, it's there. What else? In order to answer all these questions, you will need a data book. You can download that from SQA as well. That's available on the SQA site. So far, no mention of any updates to either the curriculum or the data book for next year. I know SQA are changing things in the future. So here we go. We're going to move on and we're going to look at question 12, which is one of the dreaded, at least I know all my students dread this one, is the using your knowledge of chemistry question, okay? And in this case, we have to suggest an experiment. So if you remember back to doing your assignment, you basically did this. So you're going to suggest an experiment to put, and you could do this as an assignment. This would be an excellent assignment. And you can use the reactivity series as your backup data or your comparative data from the internet. So this would be a good experiment to do for your assignment. Unfortunately, my students can't do it because whoever was in my lab before me stored the calcium on the shelf and the humidity has got into it, and now those calcium jars are full of calcium oxide and there's no calcium left. Okay, that might give you a clue to how reactive that one is. Okay, what we have to do is place these in a reactivity series. Now there's one trap here, a little bit like the fertilizer question that came before, where you might have used your biology knowledge. In this particular question, there's a trap where you might think that you could use the electrochemical series to do this, and you might get away with that because they have some similarities, but in fact the electrochemical series and the reactivity series are slightly different in the order of the metals in them, so I would avoid that. Reactivity series is what we want here. Now there's two simple ways to do this, but only one of which you have learned in National 5, really, because what you learned is that very reactive metals, so you can put this in, reactive metals, less reactivity, you can make a table, reactivity, ITY, reactivity decreases in reactions of metal with reactivity of metal, and you go with water, very reactive metals react with water, with acid, less reactive metals react with acid, and no reaction, and neither, I think we'll put in here, neither, okay? So you pop that in, that's basically how we're going to use this. I mean, the other way, if you've done a bit of extended chemistry, a bit of chemistry extension, you might know about the other thing that you could do here is displacement reactions, where the more reactive metal will displace the less reactive metal in when the solutions are mixed. But we don't learn about this. This is not on the syllabus for National 5 Chemistry. So it's if you have extended into that, that'll give you, using this method will work. I would avoid taking two electrodes and testing the voltage between them, because I know we do that experiment here, but it's electrochemical series, not reactivity series. Okay, so how do we do this? The other thing that you can remember here is a bit of your reaction rate stuff. Basically, the greater the rate of reaction, the more reactive the metal with these things here. So what I'm going to do is I'm going to test a sample of each metal in water. Okay. So the metal that reacts, any metal reacting, are most reactive. Okay, in this case we'll probably get calcium to react. Calcium will react with water, but we don't know that. So, and they are placed first. Okay, so then we have to do something else. Well, we don't really want to go to acid until we're sure. So I'm going to try using a little bit of knowledge from my rate of reaction experiment. So what will increase the rate of reaction if these metals didn't react with water? Cold water, right? In cold water, well, one of them might react in hot water. So let's try repeat with hot water, reacting metals placed next. Okay, and then you can go for, again, using our rate of reaction stuff, we can repeat. So we'll take these out, remove the metal from the experiment. What you don't want to be doing is putting a reactive metal into acid. So remove metal from test. Again, remove metal, ditto down here. Repeat with dilute acid. So any metal reacting here. So we may need to sort reactivity by, let's see, we'll sort the reactivity by measuring rate of reaction. That's if there's more than one, and we would have to do that maybe for all of these, sort reactivity by rate of reaction, but as long as you put these in without getting too confused, and then repeat if necessary with concentrated acid. Yeah, again, using our rate of reaction knowledge, we know that a higher concentration will increase the rate of reaction and probably start a reaction. So in the end, we should be able to place the metals in a series. If you want to do with water, you go metal plus H2O, put in your, will form the metal hydroxide plus H2 gas. Okay, AQ, L, and so the equations down here, and with acid, we're going to go metal plus acid reacts to form a salt plus water. And if you want to give an example, you can give an example, a balanced chemical equation of each one of those, but you don't have much time to do this. And I think if you put all that in, you're showing your knowledge of what the question means. You're showing a process, and you could do this as a flow chart if you're that well organized. You've got some time at the end. And then you could put in a couple of equations down here. And I think that should be enough to get you the 3 marks. You might want to come back at the end of the exam if you've got time and tidy that up. But otherwise, I think that's your answer to question 12 or something like that. How did you answer this question? Let me know in the comments. There's, as I say, there's different ways of doing it. If you learned about displacement reactions, that's another good way to do metals. In fact, it's you're not mucking around with acids, so it's a nicer way to do it. You just get the salts of the metals, and you can tell from the salts. But in National 5, this is the only one we really know to put a reactivity series of metals together. So National 5, this is the way I would do it. Reaction of water, acid, and no reaction. And then I should be able to put them in order. What we'll find in this reaction is that calcium will react with water, and copper probably won't react with anything. And then we have to tell tin and zinc apart in the reactions with acid. I suspect zinc will work with dilute acid and tin will work with concentrated acid. But we don't know that, and we aren't going to predict the results in this. You don't have to say what the reactivity series is, but if you wanted to put it in, it probably won't do any harm, but you need to be correct about it. That's the important thing. All right, thanks for watching. Like the video, subscribe, and that's the end of this paper. I'm going to move on to some biology papers now to help the students who are studying for this year's biology exam. I'm going to look at some past papers, 2023, 2024. Going to make some videos on that. So if you're a biology student as well this year and you're studying for your biology, you might find those videos useful. That's what we're moving on to next. Have a great day, and thanks for watching.